We've got just two more topics to do before we've done the full list of 12. And what we'll do when we get to the end is we'll look at some full exams in these sessions where we can focus on the non-calculator part for one session, and then we'll look at the calculator part for the following session. So we'll get the full exam prep sessions done after tomorrow's session. So we might even start next Monday with the full exam prep sessions. Right, so let's have a look at what we've got today. We've got angles and shapes. Generally, these sorts of questions are to do with drawing. So what I would recommend is you having a look at the NCFE website on the link. I'll send it in the email when I send out the review of the recording, and actually have a go at the online sessions exams on NCFE, purely because to get used to the tools. Like here, obviously I've not got access to the tools here, but on the exam you click on here and it creates a shape. You can click delete, you can click move it, you can click rotate it. Likewise here you can create lines. So it's just to get used to the tools, because online when I'm doing it here I don't have access to those tools because I've just copied and pasted the questions onto my page. So first question, it's a 2 marker. Let me get my blue pen going. It's a 2 marker. And what we can see here is a groundsman for an athletics club. He needs to set up a layout for a shot put event. The layout needs to be symmetrical. So the word symmetrical, same as one side as it is the other. So we know that these two angles are the same. And if we remember rightly, we've got angles in a triangle equal 180. Angles in a square or a 4-sided shape equal 360. Angles in a circle also equal 360. And angles on a flat line equal 180. So what you can see here is we've got a flat line. So we know that all these angles here add up to 180. We've got one already. And it's a calculator paper, so there's no kind of complicated doing here. So we're going to do 180 take away 34.92. Let's get our calculator. We could do 190 take away 35 and add that little bit extra on, but let's keep it in our calculator because then we've got to divide it by 2. So 180 take away 34.92 equals 145.08. 145.08, and because it said it is symmetrical, we know that these two are the same. Therefore, if we divide that number by 2, we'll have 2 angles that are the same. So let's pop our calculator back up. Where it disappeared to. Divided by 2 equals 72.54. 72.54. Not sure where that box appeared from, but can we get rid of it? Yes, we can. Okay, so that angle there, work out the size of angle A for Eric, 72.54. It's 2 marks. One for finding out the missing number, and then dividing it by 2 gives you the 2 marks. Eric, so staying with Eric, Eric wants to mark out the plot for the long jump in one section of the athletics field. The plot needs to be the shape of a rectangle with the length of 32 meters and 3 meters wide. The distance needs to be 10 meters away from the running track. So on this picture here, it shows the running track. And it's given us, oh, I forgot when I've copied and pasted this question, I forgot to click on that arrow there to make the boxes appear so that the number of squares is the right. It says here, look, that 1 centimeter equals 200 centimeters. So in other words, we've got 1 centimeter is the same as 2 meters. So 1 square is 2 meters. So first thing I would do here is look at that one there, 10 meters away from my running track. If it's 10 meters, if I put 10 here, I can see that that number's 5 times bigger. So this one needs to be 5 times bigger. We've just used direct proportion. We can see here that that's 5 times bigger. So that one needs to be 5 times bigger. So 5 centimeters, 1, 2, 3, 4, 5. So we're going to start here. That's where my blue line is. It can't be any closer to the running track than that. It has to be a width of 3 meters. So if I do it again here, 1 centimeters equals 2 meters, and I say 3, okay, that's half as big again, isn't it? So we go half as big again for that one. So we can see here, look, that for our 1 centimetre on our track is 2. We only need 3 meters, so that's 1.5. So our running track is going to be there. So we've now got the start of our track. It's going to be along here, and it's 32 meters in length. Again, we can go 1 centimetre equals 2 centimeters. We want it as 32. As we can see, that is 16 times bigger. So this one has to be 16 times bigger. So 1 times 16 is 16. And if we, and that's where I've done it wrong, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, about there, about here. It's not massively accurate, I know, because I've made a mistake by not having it in the right place. So when you click on, again, further reason why having a go and having a look at these questions, oh my gosh, that was a bit wobbly. I don't like that one there. We're about that line. Let's see if we can get that a little bit better. Not massively better. And again, the online tools, if you click on this here, it creates a square. So you just drag your square into the shape. You don't have to draw each of the 4 sides. So once you've got your measurements, so I would put my square here. I'd drag it up 1.5 because we said we needed it 1.5, and then I'd drag it along 16 because we know we need 16. So you can then not worry about my bonkers wonky lines. And we'll just double check again. We can see here, look, we've got 1 by 1. Yep, so we know that. We can see here 32. Yep, 16. 3, 1.5, 10 is 5, and we've got all the measurements there. So I'm happy with that. And I'm going to the next question. Okay. Travel agent. Marcus is a travel agent. He buys a cylindrical rotating notice board. I thought it was a lamp to display holiday offers. Draw a side elevation. Side elevation, that's in 3D. If we're looking for a plan, we're flying in our hot air balloon directly over the top, and we'd probably see something like that. And we might even see like another one in the middle, depending on if that's hollow or not. That's the plan. Looks like a fried egg, doesn't it? The front is the same as the side here because it's cylindrical. So if we're looking from the front, we're going to be looking at not the greatest front. And then also from the side will be exactly the same because it's cylindrical. It doesn't give us any scale what to use. So I would just create a similar size. I can probably see it's about 3. We don't need to put the curve on there. It's about 2 to 3 wide. There we go. Maybe it's a bit longer than that. So let's go down to there like that. Tiny little stick out of the bottom. Oh, that's gone. That's because it's playing me straight on. And again, oh no, it's not as big as that, is it? If you look at that one, it's kind of resting on something that's a bit thinner. So maybe we just go to kind of there. And again, not brilliant because I've done it freehand, but you would use these tools, straight line, straight line, straight line, straight line. It even says here, look, click on the straight line toolbox and just drag it. And that'll be the side elevation. It doesn't say label it, so we don't have to put here 3 centimeters, 4 centimeters, or a meter. It's not that. It's just a case of understanding what that side elevation looks like. We're looking at it from the side. What can we see? It's exactly the same as the front because it's a cylindrical shape. So that will be a 1 marker, in and out, draw the shape, and then done. This one's a little bit more complicated because I have never used 3D paper since I was at school, which is quite some time ago. So for 2 marks, we've got to draw this shape on our scale diagram, and the shape of the beehive is made up of symmetrical triangular prism on top of a cuboid. The dimensions are shown below: 50, 60, 90, and 80. Draw a scale diagram where 1 centimeter equals 10. So if we did it here again, look, 1 equals 10. We need a 5. That's 5 times bigger, so that's going to be the 50. If we do it this way, we need a 60. So that's going to be a 6. We need a 90. That's going to be a 9. And we need an 8. So all our measurements are literally divided by 10, because we can see here that that's the main measurement, that's centimeters, and that's squares or in our diagram. So we can clearly see that that number is 10 times smaller. So all our numbers need to be 10 times smaller. Draw a scale diagram for on the isometric paper, 1 centimeter, right? So I'm going to start here. I think I'm going to start here right at the edge, and I'm going to go 5. 1, 2, 3, 4, 5. And again, you'd use a straight tool. It says there, use a straight tool. And I'm going to go 6 across. 1, oh gosh, 1, 2, 3, 4, 5, 6. So that's that angle here I've created. I've created that square there. I'm going to go 8 up. 1, 2, 3, 4, 5, 6, 7, 8. That's that line here. I need to go 8 up here as well, because that's the same here. I've not done the 9 one yet. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Then I can draw that part in there, look. Again, I apologise for not keeping on the lines properly, but it's quite tricky. And then I can go 8 up at this side here, look. 1, 2, 3, 4, 5, 6, 7, 8. I've now got my shape here, look. I can go along here. Oh, that's my cuboid. Again, I've not quite hit that line there. And I can't go along here yet because I need that 9 in the middle. So the middle one is the third one along. So 1, 2, 3. So I'm going to go 9 up from that third one. 1, 2, 3, 4, 7, 8, 9. That's my 9th one, and I can connect my dots now. That's my roof. And don't forget, that's my apex. That's that part of the roof here. That's the apex. I can then go 5 back from there. 1, 2, 3, 4, 5, and then I can do my back part of my apex of my roof. And that's what you're going to do. It doesn't say label it, but for 2 marks, you've not got the time to kind of start creating text boxes. So you've just literally got to draw it. If you can make sure that you don't have to write this down there, but if you make sure that everything is lined up, and obviously it'd be straight lines, it would look a lot neater than that, and therefore look exactly like that, but on 3D paper. So mine looks a bit higgledy-piggledy, purely because I'm drawing freehand. Okay, ice cream shop. That sounds good, but it's a bit chilly. Luigi manages an ice cream shop. He buys wafers for his ice creams. 8 of these wafers fit together to create a circle. So in theory, I'm not talking pizza on purpose, but 8. That's 4, 5, 6. Oh my gosh! And again, not the brilliant, not the best, but to give you a better understanding of how it would look, we've got 8 of the exactly the same size wafers. These slices of pizza are not the same size, but yet we've got quarters, and then we go in again. So if we remember from that one question above, we said that a circle is 360 to go all the way around. If we just divide 360 by Luigi's 8, because he wants 8 wafers, and it's again a calculator paper. If you want to use a calculator, you absolutely can. If you think about 320 divided by 8 would be 40. So if we've got another 40 divided by 8, we should get 45 divided by 8 equals 45. But whenever you've got the chance to use a calculator, if you're confident using a calculator, do it and then check it in your head, or vice versa. Do it in your head if you're confident in using your head, and then check it on your calculator. There's no reason why you shouldn't check it on a calculator, just to be sure, purely because it's a 1 marker. It's not asking you to do a lot. So if you make a mistake on those 1 markers, it's 1 mark that you probably should have got. So it'd be a shame not to get it. Okay, let's have a look. Marco wants a shed in his garden for science equipment. That was Luigi, wasn't it? Different. Okay, a different person now. Marco wants a shed in his garden for his science equipment. He uses the coordinate grid to plan the space for the shed in his garden. The floor of the shed will be square. So all sides, oh my gosh, I should not bother drawing. All sides are equal, a square, not a rectangle where there's longer sides and shorter sides. the square are the same. The floor of the shed will be square. Points A and B are two corners of the shed. The line A and B shows one side of the shed. Write down possible coordinates for other two corners. So we need to work out how big. So it's 1, 2, 3, 4. We've got 4 by 4. So it needs to be 4 all the way around it. So we're going to go, it can go either way, can't it? Because it says the possible. If we could make our shed go, we can draw this one first. 1, 2, 3, 4. 1, 2, 3, 4. So that could be one possible answer. Again, not very straight. That'll be one angle. That'll be one angle. And then I'll quickly change color pens because we'll go the other way. 1, 2, 3, 4. 1, 2, 3, 4. So, and the other angles could be those two here. And again, not brilliantly, I know. So if we chose the blue ones, maybe because I'm right-handed, I've gone right automatically. And with the coordinates, we also remember along the corridor. And then up the stairs. For those of you watching this for the first time, and what I mean by that is we look at this number first along the corridor, and then we look at the second number as in up the stairs. Quite often, diagrams on these exams do not have them labeled X and Y. If we have got X and Y, yes, we know X is before Y in the alphabet, therefore X comes first. But if it doesn't have there, think of along the corridor and up the stairs. Horizontal, vertical, however you remember it. I've always remembered it with that little rhyme there along the corridor upstairs. So we're going to go along the corridor. It's 3, and up the stairs 1. So we can have a 3 and a 1. And then we're going to go along the corridor. It's 3 again, and up the stairs. Okay, we're going downstairs this time, but we're going to be -3, and that's our one possible ones. If we wanted to do the red ones, we could absolutely. So we got -5. The number is 1, and then we've got -5, and we've got -3. So those would have been two possible sets of coordinates you can put your shed in. You wouldn't get an extra mark for putting both. It's just write down one possible set. Okay, a boat. The diagram shows the shape of a cargo ship. That draw the plan. If you remember from what we said above, literally above, we are looking directly down onto this boat. Okay, it's told us what the back view and the front view is. The side view obviously will be this way here. That'll be the side. So we're looking directly above. It's not asked us to use a particular scale, and you've got the added bonus on this one of having the oh, it's in oh wow, cool. It's joined the plan and the side view. Brilliant. Okay, so that's quite good. We're going to draw the plan first because I'm going to draw the plan from above. We've got the straight line tool here. I've not got it. So I'm going to start at the very top and I'm going to go down, and I'm going to go down 4 squares. I shouldn't even go backwards on myself, should I? Oh gosh, rubber. No, rubber. Right, okay. Let's try again. Right. I'm going to go down 4 squares. There we go, 4 squares down, and I'm going to go along to here. Okay, I'm going to go along. I'm doing it the wrong way around. I'm doing it backwards. Okay, I'm going to go down here, 4 squares, and I'm going to go along to here. Okay, straight along. This is my plan first. Go straight along. Then the pointy bit. I'm actually going to go 2 squares from a pointy bit. And then I've got that little bit here, the back kind of, I don't know, the bit where the captain sleeps. I'm not going to be, I'm going to go half a square, half a square, half a square, half a square, half a square. And that's where I've got, that's a bit wonky. But generally, we're looking from above, that's what you see. If I look at the side angle, I'm going to stay now with, it's important, once you've done your one view, we stay in sync with our, oh gosh, if I could only do straight lines, that'd be amazing. I think if I held it on, it did it straight last time. Yes, there we go. And then again, from here, halfway. I didn't do that second time. Okay, that's my bit where my captain's leaves. Look, I've got my edge of my boat here. Look, I'm going to go. It's a straight down at the back. I'm going to go 2 squares down. I don't know why I do that. It's not good. Right, I'm going to go straight down at the back. I've got to go along to here. Look, because that's where my straight bit ended. And again, I saw myself that I'm on the sea, isn't it? And I'm going to go along to there. But as you can see, this one goes right to the end. Okay, so I've got to there. What I'm going to do then is from my straight bit here where I started with a curve is go up to that bit there. And that's my plan, is this one. And that's my side view. That one there is just a bit ropey. Let's make that a little bit better. Okay, just nice and straight. Better. Okay, and it matches up. So the important part here is that your measurements or your lines match up. So where the captain's part is there, it is here. Where the point is here, it is here. And then we've got where the edge ended here for the points to go inwards. We start that angle from there. And that is my boat. And let's go. The builder cuts a piece of wood to make a frame to lay concrete in. The diagram shows the side view of the frame. The builder thinks the angle A should be more than 170. Is he correct? How do you decide? We said above that circles equal 360. We said triangles equal 180. And we said 4-sided shapes equal 360. This is a 1, 2, 3, 4-sided shape. So all angles in this shape must add up to 360. We've been given 3 of those angles. If you're thinking, no, we haven't been given 1. We've been given 3. Look, if we have any line that suggests that is a 90-degree angle. That's a right angle. When 2 lines have a little square in the corner, that's mean it's a right angle. So we've got 2 of those. So we've got 90 and 90 at the top. So that's 180. Then we've got 7.5. So we've got 180, 7.5 for 1, 2, 3 angles. So if we take away that from 360, we're going to have our spare angle. It's a calculator paper. And again, I'm not being lazy. I'm just wanting to make sure I'm accurate first time. Minus 187.5 equals 172.5. 172.5. The builder thinks angle should be more than. Absolutely is. Is he correct for the second mark? Yes, correct. If you were to just show your workings out and not put yes, he's correct, we're getting 1 mark. So it's important that with a justification question, you actually say, is he right, is he wrong? And then the other point is for showing them how. And that is all the questions that you're going to receive on shapes and angles. If you think about the 4 exams that I've taken these questions from, we've got 1761 for that one. So there's 1 question on shapes in that one. It doesn't, oh, it's here, look, that's 2 next. So let me just pull that down. So there's 2, why is that not being? Okay, let me put, there's 2 questions from that one. 21, 26. That's this one. Okay, so only 1 question for 21, 26. 21, 32, 1. Oh, and a non-calculator 1. And then that's 2. And then there's 21, 38. There's 1 with a lamp, 1 with a running track, and 1 with the angle. So on 4 exams, there's 8 questions. There's 1 that had 1, 1 that had 3, and 2 that had 2. So in general, you're going to get 1 to 2 questions on angles. The exception there was that one here that's got 3, but generally expect 2 questions for angles with the occasional 1 and occasional 3, but generally expect 2. And if you look at them, there is 1 non-calc. Which one was it? Which one was non-calc? The drawing of 3D. The rest were calculator ones. And that is today's session. Let me stop sharing. And I'll stop recording and I'll put this on the Atom website. I'll email you all the lesson and the blanks, and I'll also email you the link to the NCFE website. Have a wonderful day. Speak to you all soon.